Hello, everybody. I'm Alain from France. I'm field application engineer since 2000 something. So today's topic, we will show you an overview regarding USB Type-C and USB Type-C power delivery, and the most important points and the most things to do regarding with the beginning. Few things about history about regarding USB and the number of device since the beginning. So from long time ago, USB 1.0 up to nowadays 3.1, which is 10 gigabits bit rate. And why, in fact, why a new connectors? Probably because this is my opinion, so maybe I'm wrong, but few years ago we were speaking about uh, charging, and the first protocol was not so interesting because it was very difficult to implement, and the micro B connectors were too big, and not a lot of customers wanted to use it, especially phone manufacturers. And the idea is due to Qualcomm and the fast charging, USB was nearly dying. So they wanted to do something new and smart. Uh, and this is the idea of Type-C, because Type-C it's 10 gigabits data rates, but in the meantime we can deliver power up to 100 watts, and we can change the supply, the voltage supply from 5 volts USB style up to 20 volts. And the idea behind was to be able to address a lot of customers, consumer, and the critical point on Type-C connectors was to think about how many times can I use it. Standard connectors are very poor in terms of a cycle, and to be able to charge, discharge your system, you must have connectors very strong and robust. And the idea behind is to improve durability, and we can have 10,000 cycles now, which means if you use it 2 times per day, you can survive 14 years. So we can address nowadays some new markets like wall sockets, and the durability, it's very, very nice. Second point was how to use it. The old connectors USB had problems, or not really problems, but if you want to plug it, you have a 50% of chance to have the wrong direction. So now the idea is to be reversible, and to avoid to think about which position, how I have to put my connectors and so on. Other points, we can use USB 2.0 as usual, and you can go up to USB 3.1, 10 gigabits. We can as well start with USB and open the door to audio accessory or some others protocol. Means with the same connectors, once the communication is okay, we can start to ask to change with HDMI or some other protocols. Means one connectors for a lot of things. And for power delivery or for supply, we can supply on the safety way with only 5 volts up to 3 amps. And we can change if we have the good connection. We can change the voltage up to 20 volt 5 amps. We will see a little later how to do that. Means we can provide 100 watts. So if I summarize, reversibility of connectors up to 100 watts, high data rate speed, and we can change the protocol, HDMI and some other style like that. Possibility to have a change on the configuration channel. We can change this one and we can supply. This is a main supply and this is a supply for the cables that we can put here. We must to be robust and we must as well to improve EMI concern regarding Type-C connectors. So we improve the shielding around the connectors. Means on EMI point of view, we are almost shielded at the connection. So less EMI issue if I consider some standard connectors like dad and mom. We can reverse the connectors and we don't think about which cable I have to use and so on. It's really important to use the connectors TID listed because we will see later the pin on the connectors are very, very tiny. The distance in between are very, very tiny, something about 150 micrometers. So if we don't use certified connectors, the risk of failure is very huge. And in the meantime, we need to provide the connectors able to handle 5 amps. How to do that? We will connect every VBus pin to have 1.25 amps per pin. So time 4 equal 5 amps. All over pin, it's 250 milliamps. That's my first point to highlight where we need to pay attention. This is the idea. If you take a look on the connectors type, you will see that VBus and GND are a little bit longer than the other pin. Means if you connect 20 volts, because you can have with power delivery 20 volts, you will have first the connection, and after you will have the ability to discuss with the configuration channel. That means if I do not protect my system, I can have 20 volts right in the face and I can damage my system just because probably if it's a standard USB, the voltage is only 5. So I will kill my device. I let you imagine an iPhone 10. I can kill my iPhone 10, 1,000 euro right away just because I didn't protect my system. So, and you can see here, if the connectors is a poor quality, distance in between is very tiny. I can have right here a connection in between 20 volts and the communication channel. So behind that, I must to protect input of my IC. And we will see later that STMicro, because we are working with STMicro for this presentation, all controllers are able to handle up to, from memory, 28 volts. So I can protect my IC, is self-protected, and I can protect my power supply. What's the idea behind? Okay. Global warming. Let's start with that. you can imagine nowadays you have a laptop, one power supply, cell phone, one power supply, tablet, one power supply, and some other still things like that. So you can travel with one, two, three, four, five different power supply, five different cables, which is not interesting because it's heavy to handle. And once failed, you have just to put it in the garbage. So one power supply, two power supply, three power supply, and some other, which is not good for the planet. So now we can just travel with one single connectors, one single cable, Type-C cable, and we can merge every power supply or even every single protocol communication through only one cable with the Type-C connectors. So what does it mean? That means every kind of system can be addressed, every kind of customer can be addressed, because from few watts up to 100 watts, we can have, and this is already the case with some system, we can have only a tiny connectors, a Type-C connectors, and we are able to provide different power supply from 5 volt, 9 volts, 15 volts, 20 volts to address different kind of market. And after consumer market, after cell phone market, because Samsung and Apple will use Type-C connectors on the cell phone, there is a second huge market, is the replacement of wall socket, standard wall socket, with only Type-C connectors coming from main supply, which means we have to use only this cable to charge laptop, cell phone, tablet, even TV. And that's a huge market. And we will see maybe later or in another presentation what are the most important improvements that we have to do to put 100 watt only on the plug socket, because the dimension are 4 centimeter per 4 centimeter per 3 centimeters, and we want to put 100 watt inside. So we need a very tiny connectors, but we need as well a new technology for IC and a new technology for transformers, because we can only dissipate probably 2 watts inside. So that means 100 watts power supply must have a very, very good efficiency. So we can discuss about GaN technology for the IC, and planar transformers with probably new materials, new ferrites, able to work at the 1 megs switching frequency. But that's another story. Interesting, but another. Let's continue with what is important if I want to design Type-C system, Type-C power delivery, Type-C power supply. I must for sure comply with the standard. So what does mean comply with the standards? That means we will see I have to have a cold socket. So I means when I put my connectors, I need to have 0 volts on my V-bus. So I need to be able to detect if I have 0 volt or no, to avoid problems or issue with 20 volts arising. I need to protect myself. I need eventually to protect the source or the sink, depending in which side of the connectors I am. I must able to detect source sinks accessory. I must to be able to discuss with the system if I'm in on power delivery. And long time ago, it was so easy to define host device or sync device just in looking on the connector styles. Nowadays, we have a Type C and Type C, it's similar. So I'm not able to detect just on if I look at, I'm not able to detect if I'm a source or if I'm a sink. So I need to replace this point by some software or some smart thing inside to be able to let the system do the job and automatically to say I'm a source, I'm a sink, and I want to change. I don't want anymore to be a source. I want to be a sink. And you can have some commercial publicity on TV with a nice woman looking for power supply, and the guy very kindly give her his cell phone. So, few points regarding how does the system work. This is not so difficult to understand. At first, there is a web-based connection, which is just hardware connection, and the configuration channel, which is here, must provide, if I'm a source, I must to provide a resistors on the source side and the resistors on the sink side to be able to detect, let's say, a current, and to be able to say, okay, the device connected is a source, or the device connected is a charge, or the host. And we will see as well, if I have 100 watts cable capability, I will have as well to be able to detect with resistors. Once done, I can or not put a second power supply to supply power to the cable, because 100 watts cable must to have some smart IC or some IC inside. So I need to supply this IC, and that's it. And this is for Type C, and if I'm power delivery, I must be able to provide through the configuration channel information regarding my capability. So which kind of power supply I can provide, let's say 5 volt 3 amps, 9 volts 2 amps, or 20 volt 5 amps. I need to inform the source, the sink, what I'm able to provide. And after discussion, we can start with one of these. So this is what I told you before. This is a resistors to be able to detect the ability of my cable. And that's an important point, because for the cable, you will have different kind of cable. Cable for power delivery up to 100 watts, or cable for communication. Which kind of cable I have to use, which kind of IC I have to put inside my cable to be able to do the job. So we must have communication in between the source and the cable to detect. So this is different configuration depending if my cable is flipped or not, just for information as an overview. Everything is done depending if my resistor is on channel 1 or channel 2, and so on and so on. So that's a few hints on power supply. So if I'm not power delivery, I will all the time provide 5 volt, because I'm not allowed to improve or increase the voltage, because I'm not able to detect, and I'm not able to discuss in between host and sink to change it. So Safety first. This is a standard voltage on USB, 5 volt. I can change only the current capability. If I want to go up, I still keep 5 volt up to 3 amps. And if I'm power delivery capable, at that moment, I can define the voltage that I want or the set of voltage that I want up to 5 amps, or better to say up to 100 watts. For your information, this is the value for the resistors provided by the standard, so you must to respect this value if you are not power delivery. You must to respect tolerances and to be sure that you can provide the right current. There is some mismatch from time to time in between 56 and 22K because for power delivery or for to supply power, we can go up to 1.5 amps. So we must use 22K ohm resistors, but from time to time, from Chinese manufacturers, we can have a difference value. And if I expect 1.5 amps, but if I receive only 500 milliamps, my system will be not happy because the time to charge my battery will be longer. So, and I'm not able to detect this default because I can't discuss. So that's a critical point when you are using low cost product, let's say. So one more time, you will see on this slide what will happen if you connect source and sink, dual role system, sink source, and so on. So this is exactly the same way to think about. At first, there is a power supply connection, GND connection, and after this is my source. So I'm able to detect the resistors. I'm able to detect if I have a smart cable or not. If yes, I need to switch from RP resistors to the supply, which is different than Webers. This is a second power supply to power cable. And the sink, this is only a sink, so the sink will present RD resistors. And in that way, on the configuration channel, so I can detect quite easily the current flowing through. So the source is able to detect, yes, this is a sink behind. No communication because we are now not power delivered yet. So there is no communication, there is only a resistance detection or current detection. That's a dual port. So dual port means I can be a source and can be a sink, and I can change when I want. So I'm a source. There is my RP resistors, and if I want to change, because let's say in the other side there is a source already, and only a source, so I can shift and change to set RD resistors to start to be a sink, and the source will be here. So this is why there is a dual port available on the market. If two dual ports are linked together, so there is no synchronization in between. So they will look for RP, RD or RP, RD resistors, and sooner or later, couple of seconds maybe, synchronization will arise because I will start to see one resistors and the other. So I can start to be source on the left side, sink on the right side, and if I'm not happy with that, I can ask to change, and we can shift, and my source can be a sink and my sink can be a source. This is just like that. That's the most critical point. If you want to convert standard connectors, so the type B, type A connectors to type C, so you must to provide a system inside providing the right resistors value. But in the meantime, and we will see, is not smart to put only resistors to be able to connect the type C. We must protect power supply. We must protect V bus, because my source can deliver 20 volts, and if I start to play with a system behind, this is automatically 5 volts is in this side. So 20 volts against 5 volts, your system can fly to the moon. Same thing if I want to go in the other side, us to think is not only good to put resistors. You must put the right value for the resistors, but you must protect the device. I repeat and repeat and repeat. Yes, it is, but this is really important to understand that point. So let's take an example. I come with a Type-C connectors. Type-C, I don't know what there is behind. So due to the length of the pin, so I said before, I will start to have my VBus connection prior to be able to check configuration channel. Means if there is 20 volts, I can burn my IC just because I put 20 volt on 5 volt pin or 3.3 volt pin, which is not good. If I'm able to monitor the bus, I will arrive with my Type-C connectors, and I will let's open the connection before to check the VBus value. If the VBus value is good, means 0 volt or below 0.8 volt to be precise. If this value is good, I can open the door, so close the MOSFET, and let's the connection and I can check with my channel configuration what's happened behind, and what is the system behind. So this is a safety way to do that. I let the connection open. First, I check the voltage. If the voltage is okay, I can turn off the MOSFET or turn on the MOSFET, and I can let the power supply flow through. Different possibilities. So I have different message available to discuss in between source and sink, and to discuss in between source and cable. Because I said before, I need to be able to discuss with the cable to see if this cable can accept 100 watt or not. And I can as well discuss with the sink behind. And the idea is to be to listen only the message that I need to listen. So start of packets for the cable is different from the beginning and the end, and it's different from the source and sink. So means every single message are only read by the the right system. So this is the possibility for the power supply, power delivery system. Safety first, so I can provide only 5 volts, and once I'm power delivery capable, I can check and change regarding the power. I can change the voltage value, which is quite interesting because I can select the voltage that I want if I compare to the power and the range of power that I want. So this is quite interesting. One example of what's happened, to just to be sure that the communication is very strong and there is a good um, interoperability and a high level of safety. If you look at what's happened on the configuration channel, you will see source start to send the message, sync say good, I received your message. I can send requests. Source say okay, I receive your request, but this is just information. So to be sure that the message that I sent has been well received, source accept, sync say okay, well received. The source say okay, I'm ready to provide power, for instance, and sync say okay, let's do it. So that's the good point. There is some communication or enhanced communication, to be sure, even if the cable is not so long, to be sure that there is no mistake and no misunderstanding in between source and so this is already done by the protocol. You don't have to do that. You just have to know how does it work, but there is no free message for you or free possibility to change the communication. You have only some specific message available when you want to change from USB to HDMI or to detect accessory. For power supply, as usual, you must to have something more than providing only power. You must to be able to protect against overcurrent, against over temperature. You must be able to detect 5 volts. As you have a cold socket, you must be able to discharge output caps, because standard tell you cold socket means the power supply at the connection will be must be below 0.8 volts. If you are not able to do that, you are not able to respect the standards and you don't have certification. And for the thing behind, this is exactly the same thing. You need to be able to protect against over voltage, over temperature, over current, and you must to be able to discharge output caps. So a few information to understand how does it work. There is few slide with some electrical schematic. We don't take a look in deep details, but it's just to have an idea. Source on the left, sink on the right, cable in between. You will be able to recognize CC channel. The bus channel, we will have a look on the output caps in the right side, up to output caps on the left side. That means here is a power supply on the left side. This is a power supply. And there is a system that's I see from STMicro part numbers. And the idea behind is to be able to provide current. This is a current source to replace RD, RP, and to be able to make the detection and to see if the system on the right side it's Type-C compatible. We must have some timing because the standards will give you some timing to provide power. So from 0 to 5 volts, for instance, you must go from 0 to 5 volt within 270 milliseconds, or at least we must to be in between under voltage and over voltage protection. If you are not able to reach this rise time, you will have a default, and you won't provide power supply because the thing behind will detect default. So that's the important thing. You must to discharge as well capacitors with some time, and this time is given by the standard. You are not allowed to do what you want, or you are not allowed to take more time to do the job. You will lose compliance. Different style to discharge caps. You can use internal path discharge because C2 it's not a so big capacitor, so we can use internal charge path discharge path through the ST part numbers. For the capacitors on the left side, this is output caps from the power supply. So depending the power supply, this capacitance value can be huge. So we must provide an external path discharge. So we have to drive it by a MOSFET. And once MOSFET is turned off, the capacitors can discharge. So you have just to calculate the time to discharge to respect standard. Nothing less and nothing more. Again, this is the same thing. To be able, worst case scenario, you can have 20 volts because you just provide 20 volts to some system, and you have to start from the beginning after the disconnection. So from 5 volt, you must to go to 0.8 volt, which is a very safe 0 volt for the cold socket. And in case of failure somewhere, if I detect different voltage, I won't turn off or turn on the switch. My switch will be off, because I'm not detecting my 0.8 volt, which is a safe way. I'm detecting some other. So if I'm detecting some other voltage here, I won't turn on my MOSFET. That's the way to protect, and that's the way that you must protect your system. You have to check first the voltage on the connectors. If there is no cold socket, you don't turn off or turn on your MOSFET to allow the supply to flow through. That's a way to burn your system if you don't do that. How can I change the voltage without too much difficulties? That's in fact just in playing with the feedback resistance. There is a couple of resistors, and to tell to the power supply behind that looks like a flyback power supply, I will just connect or not connect these resistors to the ground to change the bottom resistors to be able to change the feedback value for the power supply to change the voltage. This is easy to understand. I don't tell directly something to the power supply in terms of loop compensation and something like that. Total power supply is power supply. I'm just driving the feedback. Different way to drive the feedback. The easiest way is to play like that. So means I have to decide during the design phase which voltage I want to provide. And how can I do that? I can use software to send to the sink what are my ability, and I play with the hardware side to set the right resistance value. That's it. I can with ST micro I can control the voltage. I can control the voltage as I said with the set of resistors. This is the discharge path for the output caps. This is the discharge path inside uh, through my Weber sense to discharge C2, and I can set after discussing with the sink, I can set the right value of the resistance to provide the supply. In that example, I can provide 5 volts 3 amps, and I can provide as well 9 volt 3 amps or 15 volt 3 amps. So I can change as well the current capability in putting some protection, but this is another story. So depending the source, the sync request, I will set automatically the right switch on or off. I can drive voltage and currents. How to do that? This is quite easy in this example. So I will have a reference here that I select with the resistance. I'm able to measure the current flowing through the system. So if I'm able to measure the current with this resistor, so I will have a reference. If the voltage reference is below or above, I can set the feedback to put to keep under control, and I can play as well with the voltage here with the reference that I have here on this pin, because this is a small portion of the output voltage. So I'm able to read the voltage here, and if there is some variation, I can change quite immediately. So that's the power delivery. Minimum information or minimum overview that you have to keep in mind. And of course, power supply, it's not only power supply, but there is a lot of EMI around. So as the last part of this presentation, we'll show you which kind of component you can use to protect Type C. So this is what it is. We didn't cover communication on this presentation because we are more focusing on power supply, but just for your information, communication is up to 10 gigabits. So you know well which kind of common mode choke you can use that to protect, and you can use as well TVS diode for ESD protection. So that's a most important point. And for the 100 watts power supply, we must provide a filters. That's the set of components here. Not so big, you can see we are just using MAPI 4 millimeters per 4 millimeters with a height of 2 millimeters, able to handle 5 amps. So the filter is not so difficult to provide. And what we can see is first attenuation and the temperatures that we can have versus power. And you will see on the MAPI worst case scenario is 100 watts and the temperature is just, let's say just 64.9 degrees. So most of the time this is acceptable for customers. Of course, if you need less self-heating, you will have to change a little bit the size of the capacitors. If you take a look with the thermal camera, clear camera, you will see that the temperature is quite okay for that. You must respect height diagram for USB, of course, and you must check if there is some violation in putting connectors and component on the line with for the communication channel. So with that, you will see that impedance are nearly the same. So there is no influence with the just PCB layout. And inputting component ESD protection, so means TVS diode. TVS diodes present a very small parasitic capacitance. So that means the diagram is still good. So no issue with that if you want to be compliant with USB. Same case when you put common mode choke. Common mode choke has as well some leakage inductance and parasitic capacitance, and still is still okay. There is no violation, and so on and so on. So I think we are close to the end. Yeah, probably close to the end. What could be interesting to show you is a few information on EMI issue with power supply, because we just focus on the how to control the voltage on the power supply, but don't forget this is DC-DC converter. This is probably and most often that will be buck converters. So there is some EMI concern. Two different style, switching frequency and harmonics, and all parasitic elements that you can have, ESL, ESR, length of the track. So two different big frequency range to filters. As an example, you can see the inputs ripples without any filterings. The ripple can be very huge if you don't pay attention of that. And resonance can be very important. Resonance means this kind of wave here. So fundamentals here with a high ripple and resonance. So two different kind of frequency band that you have to filter. How to filter, that's in another story. You can put LC filters, T filters, P filters. You can put what you want, but put some. Don't let the nature do the job for you, because if not, you will have this kind of stuff at the end, and you will not be compliant with EMI, and that means no CE marking and some other, so no sales at the end of the day. For the plug or for the 100 watts, there is a flyback most of the time. Flyback, it's quite interesting to look at. The flyback is flyback, so that's power delivery. Your power delivery control system is here. You will remember the winding on the previous schematic. So you have to filters as well your power supply. Which kind of filters? Differential mode and common mode, because if you speak about 100 watt, sooner or later you will have maybe a heat sink somewhere. So you will provide differential and common mode noise inside the system. So be ready to use common mode shock on the input side, and that's the different measurements. And don't forget, so depending the frequency range, you can have common mode or differential mode dominant. So don't focus too much. If you are putting a filter on differential mode and if you still have noise, that means the dominance is from common and non-differential. So be ready to change your filters. Just as an example, which kind of value you can have, and to be sure that without filters you have no chance to be compliant with the value allowed by the standards. This is what is it. So thanks for your attention. Hope now you have a lot of good information in mind, and see you in the next session.
Hello, everybody. I'm Pascal Legrand from STMicroelectronics, application engineer, and today I will speak about USB Type-C, about USB history, evolution, Type-C and power delivery convergence, technical aspects and challenges, and then I will present STMicroelectronics solution for Type-C and power delivery application. So first, some words about USB history, evolution, Type-C power delivery, the world evolution of USB world, convergence to Type-C. What's new about Type-C? It's a same single cable to rule them all. Type-C transition in living room and Type-C transition in the office with examples. So first, the USB evolution, it started 20 years ago with a standard connectors, low speed. Then the connector goes a little bit smaller, the speed drastically increase. Connector gets even smaller with battery charging operation. Speed continue to increase and power delivery was added to this connector to go up to 20 volts, 5 amps, and then everything converged to a single Type-C connector with more than 10 gigabits per second and 100 watts. So it's not only an evolution of the connector, it's an evolution of the features and of the power. So at the beginning, we had the legacy interfaces such as PS2 cable mouse interface, UART, DB9 connector, parallel connector, game connector, and USB get a standard universal connector for those low-speed devices. On parallel of that, we had proprietary connector for charging and some data for mobile phone, for personal digital assistant. USB and proprietary connector merge with the mini B connector that allowed some charge and some data. Then the mini B connector changed to micro B connector, a little bit smaller, with some evolution of battery charging interface. On parallel of that, Apple Lightning was a reversible connector, more robust to improve the user experience because you can plug the connector in the receptacle and change upside down. So no difficulty of connector orientation. USB standard micro B, Apple Lightning together make a Type-C connector, which is reversible and compatible with USB. So same philosophy of Apple reversible connector, but standard by USB IF consortium. With power delivery on this connector, it also allowed power up to 100 watts. So replacement of the standard DC barrel, proprietary DC barrel, with extra alternate mode and the capability of high-speed data. It can also transport some video connector and be a replacement of the HDMI or DisplayPort video connector. And with more evolution, such as the Thunderbolt, it can also be a single connector to replace the business notebook docking station. The proprietary connector, docking connector that is used to connect a laptop to the office environment can be merged in a single USB Type-C connector. What's new with this Type-C connector? It's a better user experience with a reversible connector, a thinner connector, and a more robust connector. It can provide higher power up to 20 volts, so up to 100 watts, and it's higher data rate with the latest evolution with the support of Thunderbolt revision 3. It can go up to 40 gigabit per second. More convenient connector, thinner, robust, more speed with USB 3.2 and Thunderbolt. More power, scalable from 7.5 watt up to 100 watt, bidirectional upstream or downstream. The role of the connector can be changed depending on what is connected to the port. So the same connector for both ends. More protocol with PCI Express or Thunderbolt that can be transported by this connector, and more video with DisplayPort, HDMI or MHL, different standard of the video transmission that can be transported by this connector and universal cable. An example of the transition in the living room. In the living room, you can have a TV set connected to main power socket. On this TV set, you have a video player, set-top box, cable modem, something like that, connected with HDMI and also supplied with a wall adapter, an hard drive to store the films of family, something like that, connected to the video player and also connected to main power plug. And for example, a tablet that you can supply from a wall socket and connect to a TV with MHL, that is kind of video data over standard USB. So it's one connector for power supply and one connector for data. With the Type-C, you can also have a mobile phone that is charged from the TV with a standard USB cable. With the Type-C transition, you can replace the HDMI connection between the TV and the set-top box with a Type-C connector. And so the Type-C connector with power delivery can provide power from the TV to the set-top box and video from the set-top box to the TV with a single cable, so remove one power adapter. Set-top box is supplied and can also transfer data to hard disk drive and power the hard disk drive, and then remove one other power supply. Same can be done with a tablet with the same cable, and the same cable can be used for connecting a smartphone to a TV. So it's one cable that can be universal, and the TV can act as a multimedia hub with only one power supply and the same cable to connect everything. Same transition can be at the office. At the office, you plug your laptop to the power supply, then you plug to a display with, for example, DisplayPort cable. The monitor that is also supplied from the wall socket. Connect with standard USB and external keyboard and mouse. Connect to the company network with Ethernet cable, and connect with USB external hard drive for example, data backup, and this hard drive is also externally powered. Transition can happen with the Type-C connector to the monitor. Then the monitor can supply directly the laptop, so you can remove laptop power adapter. The network can be connected to the monitor is using Type-C for data transfer in bidirectional one bidirectional way. One way for video from laptop to the display, and the other bidirectional for network access. The keyboard can also be directly connected to the monitor that can act as a hub. And same, you connect an hard disk drive that is supplied directly from the laptop and then remove one extra power. Or even simple, connect directly the hard disk drive to the monitor that can act as a global hub or docking station. Some docking stations are already available for high-end notebook that can be connected only with a single Type-C Thunderbolt connector. So it's a Type-C connector with all the data going in the same cable and the power. Now we've seen that Type-C can replace everything, but of course there are some technical aspects and challenges. So we'll see the pinout and function, the Type-C state machine to change the role of the port and to detect, architecture of the power delivery negotiation, and then we will speak about protection and certification. The new connector is a 24-pin connector with many features. 4 pin for the ground, 4 pin for the VBus data, 4 differential pair that can go up to 10 gigabit per second, and some extra communication channel to either supply some electronic in the cable or in the connector, and to have a dedicated connection between the two devices. As the connector is universal, we need some intelligence in the devices to identify who is connected to who. And on the middle of the connector, it's the standard USB 2 D plus and D minus connectors. And you can see that every pin are symmetrical regarding the center of the connector to have an upside down connection, except the CC and VCon pin that are dedicated to cable orientation detection and extra communication. Type-C also use some state machine to detect the connection. So it's not only pull up, pull down resistors as the standard said. The standard also describes some behavior of how the connector should do between source sink to detect the role of the device connected. I will not explain all about the state machine, but it's something that is standardized by the USB IF consortium, and to have a compatible device, you need to follow this kind of implementation. We can see that a power source must detect a thing before connecting and putting the power. So it's just to illustrate that some intelligence must be with the connector to answer the function. Even for a dual role port that can be either source or sink, we have toggling between the two functions, and depending on what is connected, the intelligence behind the connector will go to the dedicated state. It just slides to illustrate some complexity that is in the IC or in the protocol stack. On the top of the Type-C, there is the power delivery. Power delivery was at the beginning to negotiate power up to 20 volt. The standard connection is done at 5 volts, and then there is a communication on the top of the USB connection. It's a dedicated channel to negotiate some power with a dedicated protocol stack with on both sides physical layer, protocol layer, policy engine for the communication, on parallel with the Type-C port control to identify and control of the power sink or source. Everything is normalized by the USB IF, and implementation must respect this kind of high-level architecture to be compatible with other devices. So an example of power delivery negotiation: at a connection, the source that provides the power connect to a sink at 5 volt. Then the source tell the sink what the source can do as a power budget. The source send messages to the sink telling I can do this kind of power, I can do 5 volt, I can do 9 volt, I can do everything. Then the sink must evaluate the its need according to what the source is sending, and the sink device send a message to the source to request a power, and then the source can or not accept the request, and in this case go to the power state and send the power to the sink. So it's a negotiation to change the voltage on the line. An example of negotiation: the source can also communicate with the cable, because the standard cable are rated to 3 amps, and 5 amps cable are electronically marked. This means that there is an IC in the cable that tell the source and the thing that this cable can handle up to 5 amps. Then this is the first identification of the cable by the source. Then the source sends capabilities to the sink. The sink evaluates with its own algorithm, send a request to the source. If the request match the capabilities, the source send accept to the sink and change the power and voltage. And when it's okay, the source send a power supply ready message to the sink, and then the sink can consume the negotiated power. So it's a simple example of USB power delivery negotiation, but it's messages and algorithm to adapt the needs to the capabilities that are provided by the source. About protection, we've seen that in this connector, we can have legacy devices that works at 5 volts and can draw only 100 milliamps, connected to devices that can work and supply 20 volts and with current limitation up to 5 amps. So different kind of devices can be plugged together. AC adapters, so power source, can be plugged together as the connector and receptacle is exactly the same on AC adapter, power source, and power sinks. So with a single cable, you can connect two power supply together. Power can be bidirectional, and you can connect an high-end MacBook Pro, for example, with a very, very low-cost device. And you don't know what can be at the other extremity of the cable. So it needs to be protected from non-compliant or low-cost devices, and also protection from cable issues. Even if your device is good, you can have a bad quality cable or a bad quality device or a non-compliant cable. So the port robustness philosophy is mainly the source protect the source and shall not rely on the sink for the protection. So the source must protect itself, and the same for the sink. The sink must protect itself. So you have to be protected versus external hazards. For example, Belkin is selling a Type-C power adapter with a guarantee to the end consumer. So they guarantee up to 2,000 euros connected equipment. So they are very confident in their device. An example of protection that has been seen at an USB interoperability event at Milpitas in the Type-C connector, a poor quality Type-C connector with tracked burn. The tracks are very thin. It's 0.5 millimeters pitch with 0.15 millimeter space, and you have power lead that can handle up to 1.25 amp at 12 volts, at 20 volts, sorry, very close to data, high-speed data, and very sensitive data. So to avoid this kind of poor quality, the IC that is, or the device must be protected. About certification, certification is done and supervised by the USB IF. It's mandatory to get a sticker of the USB logo. It's not mandatory to have to sell a device, but it's mandatory to have the real official logo, and it's recommended to guarantee a maximum interoperability between devices. There are at least two types of certification. Power delivery silicon only, that is a certification for components IC that are in device, and then power brick certification, that is a full power brick compatible with USB power delivery with the standard in terms of communication, in terms of interoperability, and in terms of power requirements. Some laboratories, independent laboratories, are dedicated to certification in Europe, Taiwan, Japan, China, US. Certification guarantees that the protocol and electrical specification are met in terms of USB. It helps to ensure interoperability. It guarantees the power rules for a power brick, and to certify an end product, you have to use only certified component. First step is to use certified component, and then it can lead to certification of the end product. It does not guarantee safety, security of operation. This must be done by the use of quality connector and quality design. At ST, we have many of the equipment that are used during certification, and we run certification tests for development of ICs, and we certify our devices in terms of silicon. We also do some device interoperability, and for the safety regulation, we provide evaluation board, so it's intended to evaluation and reference design. It's not certified in terms of FCC or something like that. So ST does mainly certification of the silicon component. Then a customer will use this component. It can certify the end device, and it's not mandatory but recommended, and it will be easier for the end customer as the devices inside are already certified. Even if we do some tests, we can help the end customer with pre-certification interoperability, but the end customer is responsible of the final certification of device versus the domestic safety and domestic regulations. This is the list of the official tools. 5 official tools, electrical or protocol tester that we have at ST to run pre-certification, to validate our silicon, or to run pre-certification on our reference design. And also the total phase sniffer, that is a not expensive device that allow to monitor a communication for development during development phase of a device. Independent official laboratories, one in Europe, few in the US, and mainly in Asia and Japan. A device can be sent to any of these laboratories to get an official certification. The laboratory run certification test, and then it's sent to the USB IF for validation and getting the official test ID. Then I'll speak about the solution that STMicro is offering for an easy migration from standard or dedicated power connector to Type-C in terms of source controllers and sink controllers. An overview of what we can offer devices for Type-C, power delivery, and then alternate mode with any power in standalone or associated with microcontroller for Type-C only, power delivery source, power delivery sink, or dual role with alternate mode. What does the ST controller do? It manages the Type-C port connection with the state machine that are in the standard. We follow and respect those complex state machine. Enable the power path of the VBus. On the Type-C, you must not supply a VBus if you are not connected. So STIC manage this connection and this enable of power path. And also on the sink device, you must not draw power if you are not attached correctly. So it's also managed by ST controllers. It negotiates the power capability with the power delivery protocol. It can drive the power management unit either on a source power supply or on a sink, manage the power unit with the capabilities that are negotiated. It also monitors the power path to ensure security of the device and disconnect if there is over voltage or under voltage, and protect the port by monitoring the voltage and by offering a CC line immunity and short to VBus protection. As we've seen, the power lines are very close to the data lines, so the IC must be robust. And last point, it can, for an intelligent system, report the event that happen on the line, disconnection, the power budget, the whole negotiation from a source or sink point of view. Source controllers, we have STUSB 17 family that are source type C only, but that can transform a standard power port to a type C power port and respect the standard. STUSB 47, that is power delivery controller that can negotiate up to 100 watts, and it's an interface between a power converter and a type C port. It's to migrate from a single voltage power supply to a power delivery power supply. This device must control DC-DC or AC-DC external converter. And the last device is USB 4761 that embed auto-run capability, power delivery tree source, and control directly an AC to DC converter, and also support 100 watt cable with negotiation to the cable. ST source, ST USB 17 standalone source Type-C, integrated Vcon switch, protection up to 20 volts, direct interface. It's also an IC that is certified for automotive market to change and have protected Type-C port inside the car. Size reduction of this device for making a Type-C 15 watt charging port that respect the Type-C standard. Then STUSB 47, a standalone source controller, provide drive power management unit for market of AC adapters and power supply. It's a fully autonomous device that needs no software, nothing else, that directly negotiate with the sink and control the power supply. Typical application of an intelligent Type-C power delivery port with this device that control a DC to DC converter in a fully autonomous way. It's, for example, to implement Type-C source port on a TV to connect external device that can negotiate power up to 60 or 100 watts. An evolution of this device that is currently under evaluation, that is more integrated with protection or CCCV controller, and that can be programmed directly inside the final application by the end device manufacturer. An example of the implementation that is a little bit simpler than the previous one because more features are implemented in the device. And those devices are available at evaluation kit, ST-USB47, is available at st.com as an evaluation board that is a 60-watt buck converter. So everything can be by just to plug power supply and transform a standard power supply to a Type-C power delivery power supply. We also provide a reference design of a 45-watt power brick that use ST AC to DC converter and the ST USB 47, and this power brick has been certified also by the USB consortium. So it's a reference design that can be used and is compatible with any Type-C power delivery devices. On the other point, on the other side, there is the sync device. Many devices will migrate from dedicated standard charging port to Type-C and power delivery. And for this fast migration, we propose a sync standalone fully autonomous device that will negotiate the power with an universal Type-C power delivery power source. So it can help the migration for any battery operated device that need a charge port to standard Type-C and power delivery. Typical application can be vacuum cleaner, can be LED lighting, where power needed is about 12 volts. It's also for electrical power tools, drones, camcorder, toys, many devices that every device needs a specific voltage, a specific charger. And with ST-USB 45, we can have a standard Type-C connector for the whole family of devices and have one single charger, and the power will be negotiated according to the device needs and what the power supply can offer. So it's easy plug and play feature, so easy migration, no need to go to develop firmware to read the standard. Everything is embedded in the device. It's a fast migration. Only one external power switch is recommended for operation. Many protections are already embedded in the IC. Voltage is monitoring by the IC to ensure proper connection, disconnection, and the device support dead battery function. So it means that it can negotiate without any support, any micro, any software, anything. The device is off, is connected to a power source, is supplied by the power source, and negotiate the required voltage for operation in a fully autonomous way. So it's mean time to market efficiency, very small PCB implementation, no need of a microcontroller, and a low-cost solution. Everything is integrated. So an easy implementation, an easy transition from dedicated power supply to Type-C power delivery. This device can negotiate the power and indicate to the final application which is the voltage negotiated. So it's a more complex implementation or a simpler implementation, connector, the device, and few external peripheral components to enable the power pass. The ST-USB 45 device is available on the market. It's certified and is available on an evaluation board that acts as a sync power source. So the board is available on st.com or at the distributors. It's pre-configured with internal standard power data object and can be configured by a graphical user interface available at download. And ST also provides a reference designed to show a fast and easy migration from standard connector to Type-C. So it's the minimal implementation of the Würth Elektronik Type-C connector and then the STMicro fully autonomous sync device. And it really show a fast implementation to replace the standard proprietary DC barrel by a configured Type-C port. And finally, the list of the device from STMicro that has been certified either or on sync, source device, or dual role port. The first one are microcontrollers that run the protocol power delivery protocol, and the latest devices are fully autonomous devices.